Good morning to everyone. My name is Ramesh, Assistant Professor, Department of Commerce, Soundarya Institute of Management and Science, Bangalore. Now I am going to explain. The subject is Quantitative Analysis for Business Decision 1 or Business Statistics, Bangalore University Syllabus, Unit number 4, Measures of Central Tendency. In this unit, I'm going to explain to you what is measures of central tendency and dispersion types, merits and demerits of each dispersion types, and then how to solve the problems. First, what is measures of central tendency and dispersion? Here, first we will study about the dispersion. As the name suggests that the measures of dispersion showing the scattering of the data. That means the values which is scattering or collecting, grouping of values. That values will be in the form of same kind. Same kind values we will be making as one group. In that group there will be a maximum value, minimum value or middle value or any other values which is contained in the same kind, and then collecting the group. It tells the variation of the data from one another and gives clear idea about the distribution of the data. That is called measures of dispersion. The measures of dispersion shows homogeneity or the heterogeneity of the distribution of the observation. That should be in the same observations, then same kind of data will be observed or facts will be considered. Dispersion in simple way, Professor A.L. Bowley has defined. Dispersion is the measure of the variation of the items. What does it say? Dispersion is the measure of the variation of the items. Then Spiegel is defined the degree to which the numerical data tend to spread about an average value is called the variation. What does it say? Numerical data tend to spread. How far it is spreading from the group. Then what are the requisites required when you are studying the measures of dispersion? Good measures of dispersion should have the following properties. One is it should be simple to understand and rigidly defined. It will be properly defined and easy to understand. That should be maintained. Then that will make it very good in this learning structures. It should be easy to calculate or compare. We can compare one data to another data very easily. That is why the dispersion will explain here. It should be based on all items. It should be free from sampling distribution. Sampling distribution we will study in the further years. So in that, free from that, it should be capable of further algebraic treatment. It is next level calculations or algebraic logical methods will be used. Which one? It is the measures of central dispersion. It should be remain unaffected by extreme items. Unaffected for the extreme item. Extreme item in the sense first values and last values on the given set of data. Then what are the objectives of measures of dispersion? The following are main. What are that? To test the reliability of an average. Test the reliability of an average. Average is whether it is reliable or not when we are going to take a calculation. The variation measures is the only means to test the representative character of an average. If the scatter is large, average is less reliable. On the other hand, If the scatter is very small, average is typical value. Second one, to serve as a basis for control of variability. For that, measures of dispersion are indispensable to determine the nature and find the causes of variation. When these are known, it is easy to control the variation itself. This is the way the measures of dispersion serves basis for control of variability. To compare two or more series with regard to their variability. When we are getting a two different variability, then we can able to consider, look at here, the degree of uniformity of the consistency of data can be found out through study of measures of variation and dispersion. When comparing two series as regards the reliability of the averages, due considerations may be given to dispersion, which is a good basis for comparison. Which one? Measures of dispersion. Dispersion. This is two or more types of series. Variation is there, that how will you calculate based on that measures of dispersion to facilitate as a basis for further statistical analysis. In future, we will going to study in higher studies or any research work. If it is there, there will be dispersion activities or dispersion types will be used more. That's what we will say, facilitate as a basis for further statistical analysis. The measures of dispersion are essential tool for studying the statistical tools. It is a more important when we are going to study. For example, you can take whatever we studied in the last unit, mean median mode, the same thing we are going to use, that is called central tendency. That central tendency will be applicable and will be used for further algebraic applications. At the same time, statistical analysis will be used. Characteristics of dispersion. What are the characteristics will be followed here? Here, one will be used. Ideal measure of dispersion is expected to possess the following properties. What are the properties? It should be rigidly defined. That means properly defined. Any information will be expressed in the numerically or numbers in proper way will be defined. It should be based on all the items. Each and every items in the collection of the group that should be considered and value taken for the calculation purpose. It should not be unduly affected by extreme item. It's not unduly, not necessarily will never affect the extreme item. Extreme in the sense minimum value and maximum values. It should be lend itself for algebraic manipulation. Manipulation, algebraic means calculation, normal calculation. Algebraic calculation in the sense some variable will be used and then simplified and solved by the particular values. It should be simple to understand and easy to calculate. All measures of the dispersion easy to understand and make you to calculate very easily. That purpose it is a measures of dispersion characteristics will be helpful. Classification of measures of dispersion. What are the different types is there? It will be categorized two types. One is absolute, another one is relative. First one, absolute measures of dispersion. Measures which express the scattering of observation in terms of distances. It says that range, quartile deviation. At the same time, mean deviation and standard deviation will come. The measures which express variation in terms of average, scattering observation or terms of distances, quartile and range. And then variation in terms of average of deviation, we'll talk about mean deviation and standard deviation. Relative measures of dispersion. We use the relative measures of dispersion for comparing distribution two or more set of data and for unit-free comparison. There are the coefficient of range, coefficient of mean deviation, coefficient of quartile deviation, coefficient of variation, coefficient of standard deviation. It is called the relative measure. It depends on the absolute value or absolute measures of dispersion. Then we'll talk about relative measures of dispersion. Depends on the absolute. There are two types. One is absolute measure of dispersion, second one is relative measure of dispersion. In this unit we are going to study both absolute measure of dispersion and then relative measure of dispersion. What are that absolute and then relative? Look at that. These are different types. One is range, coefficient of range, quartile deviation, coefficient of quartile deviation, mean deviation, coefficient of mean deviation, standard deviation, coefficient of variation. This is the absolute measure and relative measures. Relative measures always depends on absolute measure. Range. Now is the first part of the or first type of measures of dispersion. What are the measures of dispersion here? Range, quartile deviation, mean deviation, standard deviation. Now we are going to study about range. This is the first part of or first type of measures of dispersion, range. Now we are going to study what is range, what are the formulas will be used, what are the merits and demerits, how to solve the problems. First one, it is the simplest way of definition. The range is the difference between lowest and highest values, maximum values and minimum values. In symbol we'll use range equal to L minus S. L is largest or highest, S will be smallest value. Where L equal to largest value, S equal to smallest value. In individual observation and discrete observation, L and S are easily identified. In continuous series, the following two methods are followed. Method 1, upper boundary of the highest class interval. Method 2, yes, lower boundary of the lowest class interval. Method 2, middle value of the highest class interval, L. Second one is middle value of the lowest class interval. When we are solving this problem, we will identify it. Here I said already, here each one we are going to study relative measure. Range L minus S, that is called absolute measure. Coefficient of range, it is called a relative measure. Here coefficient of range equal to L minus S divided by L plus S. Merits. It is simple to understand. It is very easy. Anyone if I say will be understand. Here we need to remember only maximum value is what, minimum value is what. Then we can able to find out range. That is the reason. Advantages is it is simple to understand. It is easy to calculate. Each one have different understanding format. Here we need to find out maximum value is what, minimum value is what. That is understood mean then you can able to follow and we can able to find out very clearly to the problems. In certain types of problems like quality control, weather forecast, share price analysis, etc., range most widely used. What is the range of yesterday and today? What is the stock market in maximum values when it is fallen, minimum values when it is fallen? What is the difference between? So those ideas will be used here. It's called merits of advantages. Demerits. Each one have merits and demerit, advantages and disadvantages. One is it is very much affected by the extreme items because the definition itself is this range, the difference between maximum value and minimum value. or you can say in this largest value and smallest value, then we can will defect or affected by extreme items. It is based on only two extremes observation, that's all. Middle value will not be considered, that's another drawback. It cannot be calculated from open-end class interval. There is no upper limit as not mentioned in the first interval or last interval. In middle of the interval, we cannot able to understand. We cannot able to find out which is the one. There should be first interval lower limit should be mentioned. Last interval upper limit will be mentioned. If it is not mentioned, range we cannot able to find out. It is not suitable for mathematical treatment because it is simple calculation. It is not giving any further relations. So here only range we can find out. What is the difference you can find out? That's it. Will be helpful. This is very rarely used measure. Very wherever it's required. That's it. Good morning to everyone. My name is Ramesh, Assistant Professor, Department of Commerce, Soundarya Institute of Management and Science, Bangalore. I am going to explain now. The subject is Quantitative Analysis for Business Decision 1. Under this subject, unit number 4, Measures of Dispersion. Last video, I explained about measures of dispersion and range. Now, how do you calculate range? I'm going to explain now. We know that there are three different types of data. One is individual series of observation, discrete series of observation, continuous series of observation. Now we are going to study one by one individual series of observation, how to find range, discrete series of observation, how to find range, and continuous series of observation, how to find range. Here, one thing we need to be remember, whatever the different types of method of problems we studied in measures of central tendency, that is exclusive class interval, inclusive class interval, less than cumulative frequency class interval, more than cumulative frequency class interval, unequal class interval. These are the 5 methods of class interval we need to convert as exclusive class interval. Then we can solve the problems in this unit. Unit number 4, Measures of Dispersion. I am now explaining problems how to solve, how to find range. Here, individual series of observation. In this unit, we studied already absolute measure and relative measure. Absolute measure means according to the formula we will get. Based on the absolute measure, we will find relative measure, that is called coefficient. Each method or each types we will get coefficient. What are we are going to study in this unit? Range, quartile deviation, mean deviation, standard deviation. For all the 4 methods we will study coefficient. Now we are going to study individual observation, range and coefficient of range. That is what we have written. Calculate the range and its coefficient. Solution. Here we know first we need to find out largest value and smallest value. In this given value, 22 is the largest value, smallest value is 7. So formula will be written range equal to L minus S, largest value minus smallest value. 22 minus 7, we will get 15. So this is the range value. Then coefficient of range we will be find out. Coefficient of range equal to L minus S divided by L plus S. So 22 minus 7 equal to 15. 22 plus 7 equal to 29. So 15 by 29, the value is 0.517 is the coefficient of range. Then another example will be taken. Here also will find range and coefficient of range. In this place, the largest value 190, smallest value 140. We know the formula of range is L minus S. Formula, substitute the value 190 minus 140. Then the answer is 50. Range equal to 50. Then coefficient of range L minus S divided by L plus S. 190 minus 140 divided by 140 minus 140 minus 190 plus 140. 190 minus 140 divided by 190 plus 140, you'll get 50 divided by 330. So 50 divided by 330 will get 0.15151. This is the way we'll be calculating range and coefficient of range of individual series of observation. Now next, discrete series of observation. Discrete in this form of x and f will come, two rows will get. So in this, one value is fixed, number of values repeated will get. So solution in this, we need to check only in the first row, that is x column, x row. We'll be checking. In that only we need to be find what is the maximum value, what is the minimum value. Largest value of x will be 32, smallest value of x will be 4. So write the formula, range equal to L minus S, then 32 minus 4, then we'll get 28. The values of range is 28. Then coefficient of range, we need to be find. Coefficient of range formula is L minus S divided by L plus S. Here the value will be largest value is 32, smallest value is 4. So 32 minus 4 equal to 28. 32 plus 4 equal to 36. So the simplify of 28 divided by 36, 0.777. So this is the coefficient of range. Discrete series, how to find range and coefficient of range. Then another one problem. Here x values will be size, f value will be frequency. We are consider only x value. Largest value of x is 13. Smallest value of x is 3. So range L minus S divided range 13 minus 3, you will get range equal to 10. Then coefficient of range L minus S divided by L plus S, that is 13 minus 3 divided by 13 plus 3 equal to 10 by 16. 13 minus 3 equal to 10, 13 plus 3 equal to 16. So 10 by 16 we will get the values is 0.625. This is the coefficient of range. Then now two methods over, individual series of observation over, next discrete series of observation. Then now we are going to see continuous series of observation. Continuous series of observation, it is in the form of intervals 0 to 10, 10 to 20, 20 to 30. We know very well because we last unit we studied. In that will be written, because of interval we need to find out middle value. Middle value how will you find? Lower limit plus upper limit divided by 2. So we will get a middle value. So now you can find out the formula. Here two methods will be there. One method using the middle values, another one method using the upper limit. Now using the middle values we will study. Each one we found it middle value. Method 1. L equal to mid value of the highest class interval. Here what is highest class interval? 60 to 70. For that middle value 65. Then S is the mid value of the lowest class interval. It is lowest class interval is 0 to 10. Middle value is 5. So we'll get largest value 65. Smallest value is 5. So we can use the formula range equal to L minus S. You substitute 65 minus 5. So 60. Coefficient of range will get L minus S divided by L plus S. So substitute 65 minus 5 divided by 65 plus 5. So 60 divided by 70. 60 divided by 70 simplify, will get 0.8571. So this is the way we will find out range and coefficient of range of continuous series of observation. This is another problem. Is a method 2, because previous method we used as mid value. Here without using mid value we can able to solve. So solution, method 2, we know upper limit of the highest class interval will be considered as L, upper boundary, that is upper limit. Yes, smaller or smallest class interval of lower boundary, lower limit. So L equal to 50, because highest class interval is 40 to 50. In that upper limit is 50. 0, smallest value is 0, because lowest class interval is 0 to 10. So lower limit is 0. Formula range equal to L minus S. Then range equal to 50 minus 0. Then range equal to 50. Coefficient of range L minus S divided by L plus S. 50 minus 0 divided by 50 plus 0. 50 by 50. So here both values are same. Some cases will get equal to 1. Majority of the cases will come less than 1 but greater than 0. 0 point always will get the answer. In this place coefficient of range equal to 1. So here end explanation of range problems. Here some of the problems, all the three different series of observation has been given. Then we can learn and get a practice. Any doubts or any clarification, please call me. Here one more thing we need to be remember. Whatever we studied in third unit, conversion of different types of class interval into exclusive class interval or continuous series of class interval, we need to apply in this unit also. Don't forget to convert, because without converting, if you solve the problem, that is everything goes wrong. Thank you for watching. We'll see next video. Thank you. All the best for your future. Good morning to everyone. My name is Ramesh, Assistant Professor, Department of Commerce, Soundarya Institute of Management and Science, Bangalore. Now I am going to explain. Subject is Quantitative Analysis for Business Decision, Unit number 4, Measures of Dispersion. Under this topic is Quartile Deviation. This subject will come under the Bangalore University second semester BCom and second semester BBA courses. Now I am going to explain Quartile deviation, meaning, definitions, formula, how to solve the problems, and coefficient of quartile deviation in three different types of series of observation. Three different series of observation are individual series of observation, discrete series of observation, continuous series of observation. This topic is same like median How we will study median in the previous unit, that is called measures of central tendency. The same procedure we are going to follow here. First we are going to study definition of Quartile deviation. Quartile deviation is half of the difference between the first and third quartiles. Hence it is called semi-interquartile range. Any one of the unit we can take, 1 kilometer, 1 meter, 1 centimeter, whatever the measurement we are taking, equally 4 parts if you divide, that is called quartiles, 4 parts. 2 parts if you divide, that is called median. 4 parts if you divide, it's called as quartile. In that 1/4 of the value, it is called as Q1 or lower quartile or first quartile. Q2 median. Third-fourth of the values you can say it is called as upper quartile or Q3 or third quartile. Half of the values we can say it is called as median. So median concepts only we are going to study. The same way, what is the difference of the quartile deviation we are going to see here. Formula is Q3 minus Q1 divided by 2. It is called quartile deviation formula. Among the quartiles Q1, Q2 and Q3, we know very well Q2 is called as median. Q1 and Q3 we are going to study. Q1 it is called as first quartile or lower quartiles. Q3 is called as third quartile or upper quartiles. Q3 minus Q1 is called interquartile range and Q3 minus Q1 divided by 2 semi-interquartile range. Coefficient of quartile deviation. Formula is Q3 minus Q1 divided by Q3 plus Q1. What are the merits, advantages of quartile deviation? It is simple to understand and easy to calculate. Already I said here what we are going to study in quartile deviation, similar procedure of median. Previous unit what we studied, the same procedure only we are going to apply. Here, simple way to understand the quartile deviation and easy for the calculation. It is not affected by extreme values because range we seen that maximum value and minimum value will be considered, that is two extremes values, but in quartile deviation it is not required because it is a positional value. It can be calculated for data with open in classes because it is not able to close interval only, it's not possible. We can you can use for open end class interval also. Suppose upper limit and lower limit will not be mentioned, even though we can able to find out quartile deviation because quartile it is a positional value. Demerits. It is not based on all items. It is based on two positional values. What is Q1 and Q3, and ignores the extreme 50% of the items. We will be ignored because we will be taking and considering of third quartile and first quartile, that is Q3 and Q1. It is not amenable for further mathematical treatment. We cannot able to use further mathematical calculation for testing of hypothesis or distributions. The quartile deviation will not be useful. It is affected by sampling fluctuations. There is one few places sampling fluctuation will be affected. So the reason this wide application is very less. Now we are going to solve how to solve the problem. It is a problem under the individual series of observation, or we can say ungrouped data. The given values we can write. we can recall the median of will be solved. First we'll arrange in the ascending order. Then we'll find out how many values are given. The given values are odd number, there is one formula. The given values are even number, even that is another formula will be used. Given values are odd means n plus 1 divided by 2 term. Given values are even means n by 2 term. Here the same procedure will be followed. Quartile deviation. Quartile. So Q1 means first fourth of the quartile. Q3 means third fourth of the quartile. So Q1 means 1/4 of the value. Q3 means 3/4 of the value. If we keep in this mind, then we will understand how to solve this kind of problem. First we need to arrange ascending order. Need to arrange data in ascending order to find Q3 and Q1 and avoid any duplicates. That means repetition, if it is there also, we need to be considered. So the given values will be written in the ascending order: 7, 11, 12, 13, 14, 15, 16, 18, 22. Total values are 9 values. It is a odd number. So the formula is Q1 equal to 1/4 of the n plus 1th term. We know very well it is an odd number, n plus 1. There will be 2 divided by 2 used. Here 4 because 1/4 the value. Or we can say first quartile. It is Q1. Q1 equal to 1/4 of the n plus 1. Q3 means 3/4 of the n plus 1th term. Substitute the n values. 9 plus 1 divided by 4. Then you can say 1/4 of 10th term. So we can simplify that 2.5. This value lies between 2 and 3. Which one? 2.5. So we will consider second term and third term. What is second term? 11. Third term is 12. So we can use that format. Q1 equal to second term plus 1/4 of the third term and second term difference. Why you have taken here? Because 2.5 lies between 2 and 3. Suppose 3.5 is there, we need to consider 3 and 4. Okay, this is the way we need to remember what is the value you are getting. This is the formula for Q1 in individual series of observation. So 11, second term value is 11 plus 1/4 of third term is 12 minus second term is 11. Simplify, you will get 11 plus 1/4 of the 1. So then you can simplify 11 plus 0.25. So we'll get 11.25. This is called Q1 value. In similar way, Q3 value also we can find out. Calculation can be done. Q3 equal to 3/4 of the n plus 1th term. So n value 9, substitute and simplify 3/4 of 10th term. Here 7.5. Already explained the Q1. 7.5, it is lies between 7 and 8. So 7th term plus 3/4 of where that values 8th term minus 7th term, where 7th term is 16. Arranging in the ascending order, value count and take, and then 8th term is 18 and then 7th term is 16. So substitute 16 plus 3/4 of the 18 minus 16. Q3 equal to 16 plus 1.5 because 18 minus 16 is 2. 2 into 3, 6. 6 divided by 4, 1.5. So Q3 equal to 17.5. In this way Q3 will be calculated. Already we calculated Q1. Now Q3. Both we are going to use for finding quartile deviation. Quartile deviation equal to Q3 minus Q1 divided by 2. Formula 15.5 minus 11.25. 17.5 Q3, 11.25 is Q1 divided by 2, 6.25 divided by 2. Simplify, will get QD equal to 3.125. This is the way quartile deviation will be calculated. Now we know very well each thing will find out coefficient. This value, that is QD equal to 3.125, is a absolute measure. Now relative measure will be find out. Coefficient of quartile deviation. The formula is Q3 minus Q1 divided by Q3 plus Q1. Q3 value 17.5 minus 11.25 will get 6.25. Numerator simplify. Then similar way denominator 17.5 plus 11.25 will get 28.75. Simplify, 0.21739. Now we will get 6.25 divided by 28.75. In this way we can able to find out coefficient of quartile deviation. Calculate the quartile deviation. Another example I have taken. Problem. First we need to arrange in the ascending order. Here n equal to 10 values, even value, so we can find out even formula. Arranging the given values in the ascending order: 140, 145, 150, 155, 156, 169, 175, 177, 188, 190. So Q1 formula we know very well. Q1 equal to 1/4 of nth term. Here n is 10, so we'll get 1/4 of 10th. So we know very well it is a 2.5. So 2.5 is lies between 2 and 3. So second term and third term will be considered. Second term is 145, third term is 150. So we can apply in this formula. Second term plus 1/4 of the third term minus second term. So substitute in this 145 plus 1/4 of 150 minus 145. 150 minus 145, 5. 5 divided by 4, 1.25. So 145 plus 1.25 equal to 146.25. Then Q1 equal to 146.25. The values we can find out. Similar way we will find out Q3 also. Q3 formula is 3/4 of nth term. 3/4 of the nth term is, we'll get 7.5. 7.5 lies between 7 and 8. 7th term plus 3/4 of 8th term minus 7th term. Here 7th term is 175. 8th term is 177. We can substitute in this formula 175 plus 3/4 of 177 minus 175. So we'll get 175 plus 1.5. So 176.5. Q3 equal to 176.5. Then we can find out quartile deviation. Formula is Q3 minus Q1 divided by 2. So Q3 value 176.5, Q1 value 146.25 divided by 2. So 30.25 divided by 2, 15.125. In this way we can able to find out quartile deviation. Then we can, this value is called as absolute measure. Then relative measure will be finding. Relative measure is called as coefficient of quartile deviation. Q3 minus Q1 divided by Q3 plus Q1 is a formula. Substitute 176.5 minus 146.25 divided by 176.5 plus 146.25. So simplification will get 30.25 divided by 322.75. Then simplify will get 0.0937. It is a coefficient of quartile deviation. Then another problem will be considered. The given observation here is 15. First step, we need to be arranged in ascending order. Will be written in the given values in the ascending order. It's already is given in the problem itself is called a ascending order. So we no need to arrange, as it is will be written. N equal to 15. 15 is the odd number. So we can follow odd number formula, 1/4 of n plus 1 term. 1/4 of 15 plus 1 will get 16th term. 1/4 of the 16th term is 4th term. 4th term here 21. So Q1 will get as the 21 is the number. Then Q3 will be finding. Q3 can be finding here. So n will be 15 plus 1. 3/4 of that 15 plus 1 is 16. So we will get 12th term. Here is the 12th term in the ascending order is 30. Now we can find out quartile deviation. Formula is Q3 minus Q1 divided by 2. So Q3 is 30, Q1 is 21. Simplify, we will get 9 by 2. Then simplify 4.5. It is called quartile deviation. Now we can find out coefficient of quartile deviation. This is absolute value. Next, relative value. Q3 minus Q1, 30 minus 21 divided by 30 plus 21, 9 by 51, simplifying 0.1764. This is the way we can find out individual series of observation, quartile deviation and its coefficient. Now I am going to explain your discrete series of observation. The given values are like in this format. X and F it is there. We can find out. Solution. The given values can be written in the vertical form. Then we know very well here it is the concept applying for median method. So here we need to be find out CF, cumulative frequency. See that? So 4 will be written, 9 plus 4 13, 17 plus 13 30, 40 plus 30 70, 53 plus 70 123, 37 plus 123 160, 24 plus 160 184, 116 plus 184 200. In this way cumulative frequency we need to be finding. So total equal to 200. So cumulative frequency total also 200. Now Q1 equal to 1/4 of n plus capital N plus 1. Capital N here is 200. Here only one formula. So 1/4 of 200 plus 1 term. So simplify that. 201 divided by 4 will come. That is value is 50.25. The term where it lies. So it lies between 30 and 70. In that maximum is 70. So that one we can put the box here. Q1 equal to 16. This is the way we need to be find. Then Q3 also can be find in this method. Q3 formula is 3/4 of n plus 1 term. Here n is 200 plus 1. 200 plus 1 is 201 divided by 3 times of 4. So we can see 150.25 term. Where it lies? This lies between 123 and 160. In that maximum is 160. For that x value is 24. So Q3 equal to 24. So this is the way we can find out Q1 and Q3 for discrete series of observation. Q3 minus Q1 divided by 2. Q3 value is 24, Q1 value is 16 divided by 2, 8 divided by 2, quartile deviation is 4. Then coefficient of quartile deviation Q3 minus Q1 divided by Q3 plus Q1. 24 minus 16 divided by 24 plus 16. Then 8 divided by 40, 0.2. This is the way coefficient of quartile deviation for discrete series we can able to find out. This is some of the problems is given for the practice. Good morning to everyone. My name is Ramesh, Assistant Professor, Department of Commerce, Soundarya Institute of Management and Science. Now I am going to explain Quartile deviation, continuous series of observation problems. This topic will come under the unit number 4, measures of dispersion, in the subject quantitative analysis for business decision 1, or in general business statistics of Bangalore University, second semester BCom and second semester BBA courses. This video is a continuation of previous video. Previous video I explained individual series of observation and discrete series of observations, how to solve quartile deviation problems. Now I am going to explain continuous series of observation problem, how to solve quartile deviation. I am taking this problem. It's a continuous series of observation. We know very well how to solve this problem based on median concepts. The given problem will be written in the vertical form. Then we need to find cumulative frequency. 8 will be written as it is. 16 plus 8 equal to 24. 22 plus 24 equal to 46. 30 plus 46 equal to 76. 24 plus 76 equal to 100. 12 plus 100 equal to 112. 6 plus 112 equal to 118. So total frequency and cumulative frequency of the last value will be same. So the n value is correct. Then this is a continuous class interval, so we need to find out Q1 class as it is of median. So here Q1 and Q3, instead of that we can find Q1 class and Q3 class. Q1 class how to find? Q1 class equal to 1/4 of the nth term. N is here 118. So we can substitute 118 divided by 4, 29.5. 29.5, where it is lies? It lies between 24 and 46. In that, maximum value will be considered. That row is called as Q1 class. Now Q1 class equal to 20 to 30. In that, we need to find out Q1. Q1 formula equal to L plus N by 4 minus CF divided by F into I. Now L equal to lower limit of the Q1 class. N by 4, 118 divided by 4, 29.5. CF equal to 24. CF, how will you find here? In CF column, previous value of Q1 class. Here Q1 class is 20 to 30. For that CF value is 46. For that previous value 24. So CF equal to 24. F equal to 22. Frequency of the median class. I, size or difference of the median class or Q1 class. So value substitute 20 plus 29.5 minus 24 divided by 22 into 10. Then simplify 5.5 divided by 22 into 10. Then simplify, we'll get 5.5 divided by 22 into 10, we'll get 2.5 plus 20 will get 22.5. In this way Q1 will be calculated. Similar way Q3 class also we can find out. Q3 class equal to 3/4 of the nth term. 3/4 of the nth term is 88.5. It lies between 76 and 100. In that maximum is 100. For that row we can select it. That is Q3 class equal to 40 to 50. Here I explained. So Q3 class equal to 40 to 50. Q3 formula is L plus 3n by 4 minus CF divided by F into I. So L equal to 40. Lower limit of the Q3 class. 3n by 4th of n equal to 88.5. Then CF equal to 76. CF here I only find previous value of the cumulative frequency column of Q3 class. I equal to 10 because class interval size here I is 10. So L value substituted 40 plus 88.75 minus 76 divided by 24 into 10. So 88.5 minus 76 will get 12.5 divided by 24 into 10. 12.5 divided by 24 you will get 0.5208 into 10 will get 5.208 will get here as 45.208. So Q3 value is 45.208. Then Quartile deviation formula is Q3 minus Q1 divided by 2. We know Q3 value as well as Q1 value. Q3 value is 45.208. Q1 value 22.5. So divided by 2. So 22.708 divided by 2. Then simplify 11.354. This is Quartile deviation. Now coefficient of Quartile deviation, the formula is Q3 minus Q1 divided by Q3 plus Q1. So simplify that. 45.208 minus 22.5 divided by 45.208 plus 22.5. Then simplify 22.708 divided by 67.708. If you simplify this, you will get here as 0.3353. We will be getting. This is the way we can able to find out Quartile deviation. Quartile deviation, what you have to find? First Q1, Q3, then Quartile deviation, then coefficient of Quartile deviation. Then we will take another one problem. This problem is clearly indicates that it is a inclusive class interval. Whatever we studied in unit number 3, so all the applications will be used for unit number 4. Inclusive you need to convert as exclusive class interval. Suppose if it is given less than cumulative frequency problem also, you need to convert as exclusive class interval. More than exclusive class interval. Unequal class interval if it is given, then we need to convert exclusive class interval. Here in this problem is inclusive class interval is given. How will you find that? First class interval upper limit is equal to the second class interval lower limit. Similarly, second class interval upper limit equal to the third class interval lower limit. Likewise, if it is continued, then we can say it is called as exclusive class interval. Otherwise, it is called as inclusive. Here 40 to 44. Next class interval 45 to 49. Next class interval 50 to 54. So here there is no continuation. So it is called as inclusive class interval. So I'll be written in this format. First, inclusive class interval we need to convert as exclusive class interval in this form. Lower limit of all the class intervals subtract by 0.5. Upper limit add by 0.5. So we will get inclusive class interval into exclusive class interval. Then frequency will be written as it is 5, 8, 10, 11, 9, 7. So total if we added capital N equal to 50, sum of all the frequencies. Then CF, here very important because median we have found the same concept will be applicable, so that in quartile deviation we will find out cumulative frequency. So first value as it is will be returned, then 8 plus 5 equal to 13, 11 plus 13 equal to 24, 10 plus 24 equal to 34, 9 plus 34 equal to 43, 7 plus 43 equal to 50. In this way CF will be calculated. Again I will remember here continuous class interval type. So we need to find out Q1 class, then Q1, Q3 class, then Q3, then we can go for the quartile deviation and then coefficient of quartile deviation. We know that how to find Q1 class. Q1 class formula is 1/4 of nth term. So here n is 50. So 50 divided by 4 we will get as 12.5. 12.5, the value is lies between 5 and 13. In that maximum value is 13. For that row will be selected. Here we need to consider only exclusive class interval. So exclusive class interval as per this one, Qn class equal to 44.5 to 49.5. Then formula will be written Q1 equal to L plus N by 4 minus CF divided by F into I. Then the L value is lower limit of the Q1 class 44.5. N by 4, 50 divided by 4, we will get 12.5. CF equal to previous value of Q1 class in CF column. So here CF column in previous value of Q1 class is 5. I equal to 5 because difference between upper limit and lower limit of Q1 class. So here is 5. So we can substitute that L plus 12.5 minus 5 divided by 8 into 5. L value 44.5 plus 7.5 divided by 8 into 5. Simplify that, we'll get 0.9375 into 5. That if we simplify 4.6875. So plus 44.5 will get as 49.1875. This is the way we can calculate it in continuous class interval. 49.1875 is the Q1 of the given class interval. Now we can find out the same way Q3 class. Here place is not sufficient. So next slide I have shown that Q3 class equal to 3/4 of nth term. 3 by 4 of 50 is we will get as 387.5. So it lies between where 34 and 43. In that maximum is 43. That row will be selected for Q3 class. Here Q3 class is 59.5 to 64.5. Here I have shown the calculation. So now we can use the formula L plus 3n by 4 minus Cf divided by F into I. Now we can find out what is L, lower limit of the Q3 class, 59.5. 3 times of n by 4, that is 37.5. Then Cf is cumulative frequency in column, previous value of Q3 class 34. F equal to frequency of the Q3 class. I here the difference or width of the Q3 class. So we substitute in these values 59.5 plus 37.5 minus 34 divided by 9 into 5. Substitute the values. Then 59.5 plus 3.5 divided by 9 into 5. Then simplify 0.388 into 5. Then simplify, we'll get 1.944. Then plus 59.5 will get 61.444. This is the way Q3 will be calculated. Now Q1 will be calculated, Q3 also calculated. Then we can find out quartile deviation. Quartile deviation formula is Q3 minus Q1 divided by 2. So Q3 value 61.444 minus Q1 value 49.1875 divided by 2. Simplify 12.2569 divided by 2. That if you simplify, will get 6.1284. Quartile deviation value of this problem is 6.1284. Now we are going to find out coefficient of quartile deviation. Q3 minus Q1 divided by Q3 plus Q1. Q3 value 61.444 minus Q1 value 49.1875 divided by 61.444 plus 49.1875. Then you get 12.2565 divided by 110.6315. So again, if you divided this value 0.11078, this is the way quartile deviation and its coefficient will be calculated. Again, I will make you to remember whatever we studied in third unit, that is different types of class interval type converted into exclusive class interval. Few example I have shown. Similar way, any kind of class interval in different format is given. First we need to convert as exclusive class interval type. Without converting exclusive class interval type, if you solve the problem is not correct, then they won't give marks at all. Thank you for watching. Any correction or any calculation mistake is there, please let me know. You can go through the content and get the correct values. Any calculator missing is there, concept basis you learn it and go ahead. Anything is there, let me know. Thank you for watching. We'll see in the next video. Have a nice day for all. Thank you very much.